Hello everyone, and thank you all for coming. Please add your name to the attendees list. The first thing on the agenda is the status and events for CRDs. That work item is currently a P1 for 1.4, and I wanted to see what we thought about the possibility of making that a P0 and getting that for sure into 1.4. It seems to me to be the most asked for thing. Validation that's happening and appearing behind the scenes at all times, based on Oz's multi-object validation work. So, Oz, what do you think? Do you think this could be good enough to go into 1.4?
So, you hear me?
Yes.
Okay. Okay. Sorry. Okay. I think there's a prioritization problem here. I think the theme of the release is going to be about stability and reliability and user experience as well. But I think there's a more of an emphasis being placed on the reliability aspects. That's why, some of our reliability aspects in the config workgroup items are actually P0, and this is actually following up right behind it as a P1.
Okay. Even if we don't have all the validations we want in the multi-object validations, can we get, what do you think the framework is going to be ready and reliable to put status on for some of the things? I am certainly willing to lend a hand and try to get some more samples in the new framework written, especially with regard to the deprecated fields, because what I discovered is though we have warnings for deprecated types, we have no warnings for individual field deprecations. I've been talking with people about that. Is the difficulty that we want to advanced features that go through this whole framework and then eventually get out to Kubernetes, or what is the big piece that's making this difficult?
Okay, so here's the lay of the land. In Galley, there is a new config processing pipeline that I have introduced in 1.3, right? So it's off by default. And there's some well-known bugs, but otherwise it's functional. So this time around, for this quarter, I'm trying to fix its bugs and make it on by default, right? And a lot of the things actually, this multi-resource config analysis and some other things actually build on it. So in addition, there is stabilization work that we need to do in Galley all around, right? So that's essentially that part is essentially mostly about resource allocation and getting spending more bucks there, so to speak. So to enable the rest of the scenarios, so there are two other scenarios we can enable, or we can enable two scenarios. One of them is the Istio cuddle-based analysis, and I think we are kind of doing some good progress there. I think in 1.4 we should be able to provide a reasonable Istio cuddle-based experience. Now for the CRD one, we actually need to add a controller, CRD status controller, which is going to be somewhat computationally expensive, and the code that we have today is not very well tested for plant level. Right? Getting it up to a reasonable production level, even if it is alpha, is going to take some resources and efforts. And it's going to be building on this essential new config pipeline as well, which means we are kind of coupling the risks a bit as well, right? So there is a risk that the new config pipeline can have bugs, and we are adding this CRD controller on top of it, which can actually introduce more bugs. So there is this compounding of risks problem as well. I think from just a strict ordering perspective, the stabilization of Galley becomes P0, all of the work around that. But right behind that is the Istio cuddle-based experience, and I think The other work that we need to do is the API versioning thing, which is it's going to be an independent work, so we have some resource allocated for that. But I think like after the analyzers are done, I think it's going to be pretty much Chris, and then anybody who's willing to jump in is going to be the resource for the CRD status work. Does that make sense? I'm sorry, I've been jumping around a bit, like, but so there is essentially TLDR of it is there are two aspects to this, right? Managing risk and resource allocation against the strict priority order of things.
But so I think that's a very complete and good answer. So thank you. So do you think there's a possibility of an optional experimental alpha controller, or is a controller too much risk?
So I think that's certainly the goal, right? So I think if we can get an off by default, hidden behind the flag status controller that we can say, hey, flip this bit and you can play with it, I'd certainly be very happy with that, right? And that would be my goal. But I think anything beyond that is not going to be realistically possible.
Okay, that sounds great. So the next item on the agenda is this analysis of this document, which is very much related to what we just talked about for validation. Mr. Wilson, Chris, I think. Are you able to review this with us?
Yeah, I'm right. We're transferring between speakers and mics in the same room, so we're having little trickiness there. Yeah, so this is a document I wrote to kind of cover some of the additional things that seemed worth talking about on top of the original design document for this that Oz wrote some time back. So I don't know if you guys are already familiar with Oz's document. Maybe we should start there and skim over that if you guys are not.
I am familiar with it. It's this one, right?
Yeah.
Okay.
And so this kind of talks about the concepts of having a core analysis engine that works in both the Istio Cuddle and status update contexts, and also talks about having a consistent message format that we can use.
Do you want to scroll through it, or do you want me to turn over sharing to you?
You go ahead and you can scroll, that's fine.
Okay, tell me where to scroll to.
Yeah, just keep scrolling down. I'm just checking to see if there's anything here that needs to be specifically called out. I think most of us are familiar with this at this point. Okay, as this demos analyzer, all right, so the error code, that's having the structured messages. And that's the last part in here is talking about that. Okay, I hope you guys all read fast. That was a good skim. We can hop back to the other doc, I think.
So I wanted to ask about the error messages like this. Is there going to be a level like warning versus error versus info?
Yes. Okay. So these are leveled. And I think if you scroll down a bit to the, you can see here that the YAML definition includes a level for these.
So I wanted to ask about that in the context of the deprecations, because we had an issue where a field that was hidden, some people thought it was being deprecated, some people thought that it was just being hidden to see if people were using it. Is there a sense of what a deprecation message, if a field is being used that's about to be deprecated, what level are we thinking that is going to be?
That's a good question. My own inclination is basically, depending on how much you want to enforce trying to get people off, probably a warning. I mean, if you really, really want to push people off, then you can bump that up to an error sometime before you cut over. But
I was thinking the same thing, and then I was thinking that sometimes there's you would run the tool and you'd tell it, you know, that you're interested in deprecations, especially about what's going to go away. Do you think these things need inputs or flags like that, or no?
I think the more knobs and levers you add in front of the user, the less useful things are going to be. So I much prefer if we actually have a single rule set or single like principle and we apply it consistently, right? So I would say if we can, like when we can detect the use of the deprecated fields, then it should just be a warning, and it should be just one type of warning. Warning, you're using a deprecated field, and we just use it throughout without like making any exceptions or like allowances unless there's a different kind of use case for those, which I doubt there's.
I agree, and maybe there needs to be two levels of warning for deprecation because we have two versions before we remove the deprecated field. Maybe if it's going away the next version, it's an error and it's a warning if it's or a different level or something.
So I'm sorry, I missed that part. Why do you think we need two levels?
Well, I was just thinking that if the field is going to go away in the next version, that's much more serious than if the field has 6 months before it goes away.
But actually, that will require active management on our part, like trying to figure out when these fields are going to go away. I don't think we are at that maturity level in this project.
Okay.
Yeah, that's probably jumping the gun a bit to worry too much about that scenario.
That's fair.
Yeah, we do have a generic one right now, I guess.
Yeah, I mean, we can create new ones. That's essentially more of a there's a certain set of things that in an analyzer that you're going to run into, like internal error being like the most prominent one. So yeah, that's why there's like general ones, but we can make a distinction between deprecated field versus like a CERD or those kinds of errors as well, which might be more useful.
Okay. So I know there's a work item for people to, or people who've been encouraged to write things in the new framework to learn it. And I certainly am going to try to write at least one to learn this framework. Are there other people on the call who are going to be learning this framework? Maybe we should have like a day when we all try to write a framework together.
I've been wanting to, I'm trying to kind of get the demo stuff locked down and just kind of make sure that I know what I want to preach before I do it, but I would like to have kind of a workshop where we can basically sit down, I can present, okay, here's how it's supposed to work, here's the documentation, have at it, and let's see what bumps we run into.
That sounds good. Please advertise your workshop on the Slack channel or Discord, or I guess on the Slack channel.
I know a couple of the Kiali folks are going to be interested in that.
Yep. I will, so I've heard, and also Niraj, I think I'm pronouncing his name correctly, from Istio Vet was also really interested in starting to hack on these. That's it. If you want to just start hacking and experiment, you don't have to wait. We have some samples in master that include things like unit tests. So while I think we may want to refine the pattern a little bit, there at least is a pattern to follow now.
Okay. So we drilled into this document.
Mm-hmm. So that's
this one. Did we have anything about this one we wanted to say?
Yeah, so what I'd like to talk about here, so I got a couple of diagrams here just to make sure we kind of understand what the flow will look like. And so the main proposal in this document is basically that we should unify our single object validation and our multi-object validation, which we sometimes call analysis or analyzers, behind a single istio-cuttle command. We already have istio-cuttle validate that can do single object validation on files. Essentially, you can give it a file and it will treat it just like the webhook would if you tried to submit it. So we'd like to kind of unify this operation. So from a user experience point of view, you can continue to run Istio validate on files, and if there are relationships defined in those files that are broken, it will detect that. You can also run it against a live cluster or simulate the effect of applying files to a live cluster, and it will give you the union of both single object and multi-object validation problems that it detects. So that's kind of the main proposal here. At a high level, does anybody have any questions or comments about that? Okay, let's keep going. So so I also have a diagram here about galley status update, just kind of diagramming the other scenario. And we would want, let's see, I don't know if I talk about the single object validation here. So I don't want to go too deep into this. We might want to also do some single object validation in the galley status update scenario. In most cases, anything that gets admitted will have already had the single object validation done. But if, for instance, somebody has the webhook disabled or broken, it would kind of be nice to be able to still get those validation errors and have them be available in the status field. So we should be able to do that, and we should be able to accomplish both of these things essentially by wrapping the single object validation in an analyzer, or maybe more than one analyzer if it makes sense to split it up a bit.
Okay. I had one question about the file. We have had issues in the past with validation and CRDs that didn't have a namespace specified, that picked up the namespace from the default namespace. Will there be issues with, I mean, my assumption is when you run this multi-file analyzer that all of the files would be in the same namespace, but
that's not, yeah, you'd hope, but that you can't necessarily assume that. So the behavior that we have right now is basically if a namespace is specified in the file, we'll use that namespace. If no namespace is specified in the file, we will try to figure out what to inject as the namespace. So if you are running against a live cluster as well as a set of files, it will look at the cluster configuration, your context for the live cluster, and use whatever the default namespace is there. And if not, then it will just fall back to default, basically. This is also overridable with a command line flag, so that you can explicitly say, I want to use X, or I want to use whatever, default or whatever, as the namespace when another namespace is, when there's not already a namespace in the file.
okay.
So will I be able to say, you know, these three files needs to be in namespace foo, these three files needs to be in namespace for?
If you edit the files.
Okay.
You would need to edit the files to do that.
The default in the absence of an explicit one.
No. So, I mean, if you look at the entirety of scenarios, there is an advanced scenario where you have multiple files that goes to multiple namespaces, but the namespaces themselves are not actually in the files, right? So they're just maybe GitHub.
I think there's often it's a set of files that you should be able to could all apply all at once, in which case you'd have the same problem.
Right. So, well, I guess what I'm trying to get to is, like, there's one particular scenario where, you know, I have a GitHub repo, right? I have a CI/CD system. I want to use Istio as my linter, right? To be able to use my Istio as a linter, I need to be able to say, look, these files are going to go here, these files are going to go here, right?
If you run it n times on different folders.
But that's not going to work because you need to be able to say, like, these files with these namespaces, do they comply with these files with these namespaces? Or maybe even the same file with two different namespaces.
So if you want to be able to do that without specifying the namespace in the file, yeah, I can't do that right now. To be fair, kubectl can't do that either.
Yeah.
Kubectl, if you try to specify a namespace on the command line that doesn't match something that's in the file, it will blow up. It'll let you put in a default if it's not specified, but if you actually say, okay, this file has namespace default, and I'm going to say kubectl apply dash namespace foo, then it will blow up on you.
Okay. So this is really designed for integration with GitOps systems, right? Where your file system is the source of truth for what's in your cluster, and you want to make an iterative change to the file system, check its validation, and then deploy it. I recommend then, for the situation with multiple namespaces, that we just evaluate GitOps tools like Flux and see how they solve the namespacing problem. It's a problem they will have run into as well, and so they ought to have some sort of solution for it. And I'd hate to reinvent the wheel here.
That's for totally reasonable. I'm just bringing it up because it's just a kind of a sake of completeness thing rather than
Yeah.
Okay.
Related to this is Jason from Google is doing OpenAPI schemas for CRDs. And that if you do there's a way to do it like a client-side dry run. Will those schemas be validated by this analyzer or not?
So schema validation is kind of in the domain of single object validation, and I'm not paying a whole lot of attention to that, except in the sense that we can wrap our single object validation inside of an analyzer.
Yeah, I think basically the approach that we're taking now is the schema that we are having is basically a structural schema. So it doesn't have too much constraint. We'll still rely on the webhook, existing webhook, to do most of the single object validation. Although the OpenAPI spec can actually express more validations, but right now for the CRDs, it's very limited.
So for single object, currently we're calling these handwritten validate messages. And we have a little bit of extra code to make sure there's no unknown keys before it's converted into a Istio CRD internal model representation. But and that's the same code that the webhook uses. But when we run this thing as a pure Istio cuddle command line, if it's possible to invoke that schema validation without sending it to the webhook, we're going to want that. We'll also probably have to write a method for the deprecations, which probably can't be done through the existing validate because it doesn't have like a deprecation output field. So I'm thinking that every Istio CRD, in addition to the validate method, needs like a deprecate warning type thing and a schema, and then there should be a generic schema validator if we have a schema for that CRD. And that's just for the single objects, and we would just hook them into this framework.
Yeah.
So, okay, let me understand this a bit, right? So you mentioned two things actually, like the extraneous fields in the configuration, which we are allowing to be ingested for the most part, but we don't want to actually have a command line validator to pass, so you want different behavior. Is that correct?
For the I believe for the webhook and definitely for the command line, I wrote stuff to make sure there were no extra fields because like in Istio 1.0, it would get converted and then those fields would be thrown away, and you wouldn't notice if you had screwed up your tabbing in your YAML files, where a field that had like a well-known name was untabbed, so it became a top-level field and then it was thrown away. So having a schema validator would be great, so we can throw away that code and replace it with a nice schema validation, just to make sure there's no unknown top-level keys and that kind of thing.
Okay. I think we should keep it as a something that we need to test for. I suspect we may be able to come up with different approaches to solve that one. One approach that can certainly be running the OpenAPI schema against the input and having that output, but we can also potentially use some other mechanisms. Maybe we can deduce some of it during proto-parsing.
Okay.
But yeah, so I think that's a good point. We should certainly have essential tests for those particular cases, and even maybe well-defined error messages.
Some people, instead of using Istio cuddle validate, will use kubectl apply server dry run.
Mm-hmm.
That's the story behind that. Okay. Should I continue scrolling?
Yeah, go ahead and scroll down. So what I've got here is, so like I mentioned before, kind of the core proposal that that I wanted to really get at is unifying both single and multi-object validation behind the existing Istio Cuddle Validate API. So this is a behavior change for this API in the sense that we are extending it.
Okay, so here's the current one.
Right, so that's the current one.
And here's the new one.
Right.
With
It's kind of like, yeah, it's kind of a delta view of it, I guess. It's
okay.
So we're still inheriting kind of the same set of shared flags. So the main things we need to add, so we need to be able to say, okay, we need to be able to support the live cluster case. So we need some way to flag that that's what we want. We already have arguments that can specify the kube config and context to use once we know we want to use Kubernetes. So that's what that's for. This YAML output is just so that if you want the output of this to be easier to be machine parsed, you can just have the output validation messages in YAML format rather than pretty printed for human consumption.
That makes sense, although it might be nice to do -O equals YAML so that you could have JSON or something else the way other kube tools do.
Yeah, can you add that as a comment, please?
Sure.
It's also consistent with kubectl and how that does that.
So I also added a comment to this document. I remember about having subverbs.
Yes, and there was I think we should talk about that. I think that's something worth talking about. So we'll come back to that in a second.
Sure.
So one other thing that I was thinking about, and this might be somewhat controversial, is I really like the idea of using positional arguments rather to specify the file names rather than doing -f for each file. I think this makes it a lot easier to use as a user just because you can take advantage of stuff like bash expansion, the glob expansion. So you can do, folder/star, folder/**/* if you're doing, recursive stuff and have that set up. It's a fairly standard thing for tools. A lot of Unix-based tools work that way. But it is a change from the existing behavior. So I think we would want to keep supporting -f if you wanted to do it that way, but I would like to be able to do just...
I agree. -f is often used for standard in. Do you have a proposal for standard in if you're using positional? I'll just add a comment here.
You can do it just by redirecting standard into the pseudo file thing you can do in a shell. I don't know if it would work out of the box to do like -f. Yeah, I don't know if that will work directly or not with our existing tooling.
Well, I was just thinking if you specified no, I guess you could, you could use bashisms here. Okay.
Yeah, question on Istio Validate. Is it intended to use after people apply the Istio resources to Kubernetes, or is it intended to use before?
That's a good question. So today it's intended to use before, and it can't look at what's on a live cluster at all. It can only look at files. That said, you can do kubectl get, pipe that output into a file, or I think even straight into Istio Cuddle Validate if you want to do it that way. It's a little awkward.
It is awkward. Yeah, that's what triggers my second question is, do we believe there's value to issue Istio CTL Validate against, let's say, if I remember my virtual service resource, and then I can just specify my virtual service resource. And also, can we do like validate for my given namespace if that's one single namespace I'm interested in?
So one of the things that I'm proposing adding essentially is that we can also validate against a live cluster. Now, I haven't put anything in that lets you filter that down further. So right now, it's basically looking at everything that everything in the cluster, essentially. And if we wanted to filter that down further and just kind of subscope the analysis.
Yeah, I think it would be interesting to do at the namespace level and even for a given resource, because you may not own everything in the cluster, and also you might have multiple apps in the cluster, and you may only be interested in certain things.
So I think scoping things by namespace could work. So this is essentially using some of the Galley libraries, and Galley also needs to be able to have the ability to be scoped as single namespace. That's not implemented, but it is something relatively straightforward to add. Once we add it, this mechanism should just follow through, right? We should be able to use the exact same mechanism here to actually restrict things to a single namespace. Now, when it comes to a single resource, I think it's not going to be that easy, because the single resource, like if you try to write a design, like an analyzer that's attached to the single resource, you need to something that's going to actually do like on-demand fetches, right? So it's not going to, the system doesn't work that way. The system looks at a set of configuration as a whole and just gives you the whole set of diagnostic messages. Having said that,
have like kubectl get gateway and specify your gateway name, so you can get up the resource definition pretty quickly.
Yes, but okay. So let's assume that you want to show the set of virtual services or analyze the virtual services that depends on this gateway, right? So you need to go and do a query across virtual services that references this thing, right? So that's why that's why the problem is about having multiple resources and their dependencies among each other, right? Now, having said that, once we create a set of diagnostic messages, we can certainly filter them out so that you only see the things that pertain to a particular resource. In fact, that's how the CRD status controller works, right? So it generates a whole bunch of diagnostic messages and then finds the correct target for them and updates only those resources.
So what this practically means is that when you have the status update field stuff turned on, when we add that in, you will be able to do kubectl get on a resource, and you'll be able to see in the output field that says, hey, here are your validation errors associated with this resource.
Right, yeah, I understand when status is available. I'm just trying to understand the value of validate. If we can't validate, let me give you an example. Let's say I have a.yaml is my gateway resource, b.yaml is my virtual service resource. And I could apply that a.yaml and b.yaml when I apply to the same namespace. That's perfectly valid and perfectly okay. However, if I choose to deploy a.yaml into Istio system for my gateway resource and b.yaml to my virtual service to my maybe default namespace, and there's probably an issue if I don't update my b.yaml to reply to the new location of the gateway resource.
Mm-hmm.
So I'm just trying to understand how is your validation will be able to validate those type of problems if you don't take it into consideration of which namespace.
It does pay attention to namespaces. So to be clear, if your namespaces are defined in the YAML files, especially in that case, then it will pay attention to whether or not they can correctly reference each other.
But namespace defined in the YAML file is not a hard requirement today. People could choose to deploy live, right? They could the namespace lively.
So remember the thing that I brought up like maybe 10 minutes ago, right? Where can I have a bunch of files that I say I'm going to deploy to namespace A, and there's another bunch of files that I'm going to deploy to namespace B, right? Yeah, so that's the scenario you're actually talking about. Right? Being able to, within the same session, say this file goes to namespace A versus this file goes to namespace B, right? And I think functionally implementing that should not be hard. right? So it's just that, you need to expose it through the command line or through whatever input mechanism that we give to the user, right? But once we have that mechanism, I think it's fairly straightforward to handle that case in terms of the system.
It's too complex to have it take an input file which describes the set of files and then rather than having to spell them out on the really long command line.
Yeah, I mean, you can think of many different solutions. This could be one of them, right? But essentially, the tool, the common use case that I think we're targeting at this point is based on kubectl apply. The assumption is the scope of analysis that you are doing is for the scope of your kubectl apply that you're going to call just now.
Right. The assumption is that the things you're looking at, you're treating them as a unit.
Right.
So can you start with that and see where it takes us?
Yeah.
Yep.
Okay. So we have another page here, but we also want to get to Tauhid's demo of Istio Cuddle List because I think we'll have some questions for him. Do we want to finish up the formatting of the metadata?
One last thing I wanted to talk about is what Oz was bringing up, and this is a question I really would like to talk about with this group, is whether we should model the different use scenarios as subcommands. So if you go back up to the examples, you can see I've got basically three kind of use cases here. There's files only, there's a live cluster only, and then there's simulating applying files to a live cluster. Oz was pointing out that it may be easier for the user if we model these as subcommands so that they're kind of clearly different verbs for these different cases.
So in the comment that I put there,
yeah,
actually, Ed, could you scroll down a bit? So see that comment from me. Can you expand the first line, like the item?
Expand which item?
The comments that I have on the right-hand side.
It says show more.
Go to the right. Yeah, that one. So essentially, there are three different scenarios there, and I think they are fundamentally different, right? This is is my on-disk configuration good? Is my configured cluster good? And what happens if I apply these to the cluster, right? So these are actually three different tasks. And I think it may make sense to actually have subverbs to describe these things, right? I just gave the examples here. You can actually say Istio Cuddle analyze files, and you're just pointing to files. You can say Istio analyze cluster, and you're just pointing to a cluster and just looking at the current set of things. And then you can say Istio Cuddle analyze apply, which asks this question, okay, what happens if I apply these files to the cluster? Right? I think these are three different subtasks, and if you let the user try to do these subtasks purely based on which flags that they specify or don't specify, I think it's going to get a bit confusing on the command line.
The user might not realize that the two options give you these three possibilities.
Exactly. Right.
Well, that's so with the way I've tried to tackle this so far, and I fully acknowledge that it may not be sufficient, is just by trying to have good examples. And this is something I model this in the way I've seen other Unix tools do it, where you have a billion options, and then they try to make that usable by having examples that are very clear about the specific use cases that are most common.
I kind of like the two commands here. When I look at these examples, it becomes clear. When I look at the three subcommands, it seems like, well, what am I doing? I got some files. I must want to use this one. But wait, no, I want to analyze applying the files versus just having the files. So I kind of like the original proposal. What do you guys think?
More voices? Anybody? Anybody care?
Oh, sorry, I was talking on mute. I think the kube config is confusing because we don't really ask user to specify kube config today over istio-ctl commands. The convention is people change their kube config into kubectl, and then istio-ctl would just grab the latest kube config file.
I think in this example Oz wrote, those kubeconfig settings can be taken as optional.
Yeah. So I mean, you can use the same command line settings to specify them, and you can also omit them, which means you're going to be using the default, right? All you need to write is Istio cuddle analyze cluster, and it will just do that.
Okay. Yeah. I guess what I'm trying to think. I mean, if I'm a user, if I'm using using the validation tool, I guess I would like to have the YAML file to be rejected when I apply. Ideally, I don't have to remember to run the validate before I apply the YAML file.
This is an interesting case because we do, in fact, reject it today if it's for single object validation errors. So if there's something broken in your schema, for instance, then we will, in fact, reject it at kubectl apply time.
Okay, that's perfect. And then if I do analyze, I would think I want to apply to objects that's already being applied to my cube. So I wouldn't be interested to find what files I applied. I think I would be more interested to specify these are the resources I know in my cluster, whether it's my cluster name or whether it's my namespace within my cluster or whether it's a given resource or multiple resources within the cluster.
Right.
Because you almost feel like the files you would need at apply time, and then you use validate onto a given object within the cluster. I mean, that if you look at like the describe command, I think it's also specified that way too. Once your resources have been applied, then you use the describe command on a pod or maybe a deployment down the road to figure out what's going on.
Maybe I'm confused here, right? So essentially, once we have the CRD status, that's where you're going to look, right? You know, you can say kubectl get that resource, and you will immediately see the results, or like the diagnostic outputs of what's wrong with that resource.
Are you saying the analyze is a step in between?
This is before you apply to tell if it's going to succeed or not.
So these are three distinct scenarios, right? So the first one is analyze files. I have a bunch of files. I haven't applied it. You know, all I am asking is, as a coherent set, are these good, right? Can I apply them to maybe an empty cluster and will everything work fine? The second one says, you know, in the absence of a CRD status field, look, I just want to point this tool to the live cluster and just get the exact same diagnostic information by just looking at the resources in there. And ideally, if we have the CRD status enabled, it will show the exact same error messages that is reflected in multiple different CRD status fields. It's just going to give you the full complete set based on its own analysis. And the final thing says, the analyze apply, you know, I have an existing cluster with a bunch of resources in it. I want to apply these files using kubectl apply. If I do that, what's going to happen? Are there going to be any issues, right?
And that has an advantage of individual apply, is because it analyzes all these files together before apply them?
It's analyzing the files together and also against what's in the live cluster. So in the case where you already have your gateways set up on the live cluster and you're adding a new virtual service, if you happen to have a typo in your virtual service YAML file where it's not pointing at the right gateway, this would detect that.
If we say there is a demo by Tao that he's waiting to do, if we should take it.
Yeah, we should move on. I think we've taken more than enough time on this already.
Yeah, I think I like the validate command better than the analyze. So yeah, that's my
Okay. Well, I would really appreciate it if everybody can record their thoughts in the doc. Whatever thoughts you have, please write them down. Don't be shy. The more written down stuff there is, the more we can do with it. Thank you again.
Sure.
Tao, can you do your demo now?
Yeah, can I share my screen?
Yes, you may.
Can everybody see my screen now?
Yes.
Okay, let's start. Hello everyone, this is Tao from Google, and I'm going to do a demo of a new command in Istio kernel, and we call it Istio kernel list. And about me, I'm mostly working on the Istio operator, and this command is like a side project for our work in multi-cluster created by multi-cluster command created by Jason Young, and when we're working on that, this is the command we're trying to track the issues and see the internal status in Istio Pinerd. And about the motivation of this command is developers of Istio get the runtime information about the mesh in Pinerd using the Pinerd endpoint, debug endpoints, and debug anything else, and dump all the thousands of lines of JSON information and trying to pass it into its internal status and trying to understand it, trying to track the status and trying to debug. And there's no COI tool to retrieve those information and convert it into a human readable and user-friendly format. And only use a kubectl. You can describe the CRD, you can describe the pod and service, but you cannot describe the status in the Istio mesh. For example, the multi-cluster information, like the remote service in another cluster, which was registered in the current mesh. And for sidecar proxy, we already have a command, Istio kernel proxy config, to retrieve the information and get it into a human readable format, and it's already in the Istio kernel release. So the idea for the new command is we need a similar Istio kernel command for the Pinerd information to describe the internal status for the mesh. And in this demo, we're going to show you some type commands for the Istio kernel. The first one is Istio kernel list clusters. This concept command will list out all the clusters registered in this Istio control plane. And the first column is the cluster, if this is the current cluster or it is a cluster in the remote side we're watching. Because from the multi-clusters mechanism, you add a remote cluster in the current control plane, it means you are watching the API server from the remote. And without this command, only use a kubectl, you can describe the API server by using this long kubectl command. And you can get only one API server's IP address. And you, because Kubernetes doesn't know anything about the multi-cluster mesh, so you cannot describe the multi-cluster which was registered into this service mesh. And the second one is describe all the services discovered by Istio.
Can you go back to
Istio? Sorry.
Can you go back to the previous slide? So, the fields here, the columns, there's only a few columns here, the cluster and API server, port and protocol. Is it possible to get more information about the other clusters, maybe the name of the Kubernetes cluster or anything else of value?
I was trying to do that, but I cannot find anything else. I can only find one more thing is the secret name we use to connect to the remote cluster.
I would find it, I mean, this is better than nothing. I would find it though difficult to understand what was happening with only these columns. Is it that you need Pilot's debug endpoint to offer more information, or what would make this more useful?
That's a great question. I think we can modify the debug endpoint to provide more information about that cluster, like the cluster name, the locality, and which is the provider, and things like that to help the user understand those information.
It might be good for 1.4 to have a new endpoint or an alternate endpoint that offers more information that then works with this. Trying to build a CLI just out of the current information, I think would be frustrating to figure out what I'm seeing.
Yeah, I agree with you. That's a great point. I will try to.
Okay, so let's continue.
By the way, is this only for single control plane where you list the clusters as part of the single control plane?
Yes, this is a command like provide information from the view of the current pilot in one control plane. That means the response shows what the pilot can see for this mesh.
Okay.
If pilot has scaled up to 2 pilots, do all the pilots know about all the clusters?
Yeah, I will list out all the information in all the pilot pods and doing some dedupe things for those information.
But this does hit all of the pilots. Okay.
Yeah, it is. And the next one is list out all the services discovered by Istio and all the IP address for them.
And the reason you didn't show cluster here is because all the services are propagated to each of the cluster?
Yes, because when you add one cluster into the service mesh, it is possible you cannot describe one kubectl to get the information from the remote pod.
Is there any way to tell for a service like product page which clusters have it?
Can you count again?
If I have 3 remote clusters that I'm watching, maybe one of them has product page. Is there a way to add a column to tell me which clusters are associated with the service? Pilot knows.
Yeah, that was my question too, Tao. My guess is this is only single control plane, so it's on every single cluster.
So the question is, we don't have the connection between the service, one specific service to a cluster, right?
Jason, were you trying to chime in?
Yeah, I don't know. Can you hear me?
Yeah.
Okay. I think more precisely, it's not the cluster, it's the service registry. And so Pilot, if it doesn't have that information, that's reasonable. You could reverse map that back to a cluster, but we're not always going to find a matching cluster. If you were integrating with MCP directly, for example.
I think it would be tremendously useful to have that information. Because now you tell people how many clusters they have, and then you tell people how many services they have, but they have no clue which services runs on which of the cluster.
Even if in some cases we could tell, in other cases we didn't know, it would be great to tell if we did know.
I agree. I think the pilot should be able to know those connections between service and cluster. And I can try to do more deep dive into the debugging endpoints to see if we can find those information and list it out into those response in this command.
Thank you, Tao.
Yeah, because I can see the API server address and the mapping to the address to the API server to one port. I'm not sure I can find more inside that. And without this command, you need to do debugging to dump the pilot registry endpoints, and there's thousands of lines of output for this, and you need to manually parse the result and trying to understand what's happening inside pilot.
Okay.
The next one is quite similar, but they are for the endpoints and the ports. So those examples shows the endpoints for review service, and the second one shows the pod for the review service. And here's a demo setup, and we have 3 clusters in different regions, and we have book info demo installed on each cluster. And for cluster 1, it only has a review v1 service, and cluster 2 only wants review v2 wants black star ratings, and cluster 3 wants review v3 wants red star ratings. And at the beginning of this demo, they are separated from each other, and it's like this, the topology. And cluster 1, review 1, cluster 2, review 2, cluster 3, review 3. And the next step is we're going to add the cluster 2 and cluster 3 into the service mesh of cluster 1, which means the Istio control plane is going to watch the API server for cluster 2 and cluster 3, and the Envoy sidecar is able to send traffic to cluster 2 and cluster 3 from cluster 1. And it's a basic multi-cluster setup for those. And the last step is we're going to take down the review service in cluster 1, which is a user scenario like cluster 1. In this data center, this service is not available anymore, and we still have fallback logic and to make this system highly available.
I like these slides. Can you add them to the document that's linked, or put a link to this slide deck?
I will add it into the today's meeting.
Thank you.
And I will show you the demo now. Can you see my screen?
Yes.
Here. So we have 3 browsers, and the first one is a cluster 1 without any ratings and only has reviews from customers. It's a book info demo. And this second one is cluster 2 with only black star ratings. And this is cluster 3 with red star ratings. And for cluster 1, I'm going to add a auto refresh here. So it will automatically refresh this page. And what I'm going to do, I'm going to show, we have those list commands here on the right side of this terminal. Can you guys see this terminal?
Yeah.
Yes, you can see it.
And from the first panel, I will keep running the list clusters. But now there's only one cluster registered into this service mesh. And for the second panel, I'm going to list all the services registered into this service mesh. In the third panel, I'm going to show all the endpoints for the review service. For now, we only have one review service, which is v1 in cluster 1. And the last command is we're going to show the port for review service. And we keep calling those commands every 2 seconds by using the watch command. Now when the command create remote secret created by Jason Young, this command is used to add a remote cluster into the current mesh. Now I'm copying the command to create a secret in cluster 2 and pipe it into cluster 1 and apply it to create a new secret in cluster 1. So the cluster 1 is able to access cluster 2 to get all the services and all the pods in cluster 2. Basically, it enables the multi-cluster mode for cluster 1. After applying this, the secret get created in cluster 1, and cluster 1 is able to access cluster 2. And you can see in the current match, we can see there are two clusters in this match, and there's a API server address. And for each services, there are two IP address for them. And for the review service, there are two endpoints for it. And we can even see the locality for each of them. Because those two clusters, they are located in different regions. We can see the different here. And for the pod, it's the same. And I'm going to add one more cluster into this service mesh by using basically the same command. So the cluster 3 secret is created in the cluster 1, and cluster 1 is able to get a similar information for it. And going back to the browser, in the cluster 1's endpoint, you can see the ratings randomly hit the review service in 3 different clusters. And once you take down the service in cluster 1, it is still available for the end users. So with this command, we're going to take down the review service in cluster 1. And once it's done, the service discovery and the endpoint discovery will show the update for, we have one as endpoint registered in the service mesh. And from the end user side, there's no review without ratings, which means the user cannot access the review V1 service because it's down. But the whole product itself is still available.
Thank you for this demo, Tahi. This is good.
Can I ask one quick question before we end? Is this code already in master? Because we need to look into add this for other multi-cluster model beyond just the flat networking you showed.
The multi-cluster, the create remote secret is already pushed into the master, but the kubectl list is not yet.
kubectl list has a PR that you can try out. But yeah,
you can try it out.
There.
Okay, thank you. Well, really good. Good demo.
Great. So we went a little over time. The last thing was we were going to talk about testing Kiali, but I can just talk about that separately with the Kiali folks. So I think this concludes the meeting unless we have anything else. Please add any items you want to see to the agenda for 2 weeks from now, and follow along with the validation work, which I think is the most important part of this 1-4 cycle for user experience. Thank you, everyone.
Thank you, guys.
Thank you, everyone. Thank you, Ed.